Hello everyone, myself Sandesh Godavi, studying in Sri Venkateswara College of Engineering, SVCE Bangalore. Uh, Today topic is RSA algorithm, how RSA algorithm works. Today's agenda is what is RSA algorithm and example, and as usual use cases and future of the RSA algorithm, what will be future of RSA algorithm and summary. Let us begin with introduction. RSA is a widely used public key crypto system designed by Roy Revest and Adam Samir and Leonard Halidman in 1977. It relies on the mathematical properties of larger prime numbers for secure communications, and RSA is a versatile and widely employed in various security applications, including source email communication, digital signatures, SSLs, and TSLs for secure web browsing, and as a fundamental building blocks for hybrid crypto system. As one of the earliest practical public key crypto system, RSA foundation for modern cryptography, inspiring future development and advancement in the field of source communications and protections. Uh, it will be having public and private keys. RSA uses a pair of keys, a public key for the encryption and private key for the decryption. Whatever the code is sent by the user will be right, that will be the public key, and the private key who is decoding the code, right, they will having the private key, that is known as public and private key. And public key is shared only, uh, while the private key is kept secret. Messages encrypted with the public key can only be decrypted with the corresponding public key. uh, the three basic steps are key generation and encryption, and decryption. This is the algorithm for RSA. Select PQ and PQ are both are prime number, that where we have to choose two prime numbers where P should not be equal to the Q, and you should calculate the n where n is equals to P star Q and calculate the phi of n. How to calculate the phi of n means we will having the P and Q, right, we have to minus with 1 and multiply each other, then the phi of n will be calculated. Select the integer e. GCD of phi of n comma e should be equal to 1, where 1 is greater than e and e should be less than phi of n. Yeah, and then we have to calculate d. D is equals to e minus 1 mod of phi of n, and public key pu is equals to e comma n. Whatever will generate e and n, right, that will be the public key, and private key will be the d and n. Encryption formula is c is equals to uh, uh, p n mod n, means what will be the public key and e, right, that will be mod of n, and description is plain text is cd uh, mod of n. Let us see one example of algorithm. uh, Choose p is equals to 3 and q is equals to 11. While we are choosing p is a prime number and q is also a prime number which is not equal to each other, p should not be equal to q, and we are computing the n, where n is equals to p star q. As we showed in the algorithm, to calculate n, what is the formula? P into q. So 3 into 11, that is equals to 33. We have calculated the n and we know the prime numbers 3 and 11. Now we have to compute the phi of n. How to calculate the phi of n? P minus 1 into q minus 1. What is the p? P is 3. 3 minus 1 is 2. And q is 11. 11 minus 1 is 10. 2 into 10 is 20. And then we have to choose e such that e should be greater than 1 and it should be less than phi of n. And e and phi of n are coprime. Let e should be 7. So when phi of n is 20, then 7 we have chosen, right, e as a 7, then it is greater than 1 and it is also lesser than uh, 11, sorry, 20 phi of n. Then we have to compute a value for the d. such that d star e mod phi of n that is equals to 1. So one solution is d is equals to 3, 3 star 7 mod 20 is equals to 1. Then next we have public key generation is e comma n, that is 7 comma 33. This will be the public key, and private key will be 3 comma 33. Okay, next encryption. How to encrypt the plain text? No, when m is equals to 2, then we are encrypting that using the public key, right? So 27 mod, that is 27 mod 33 is equals to 29, and we are decryption of c is uh, that is m is equals to 293 mod 33, that is equals to 2. Next, use cases where under this RSA algorithm will be used. Secure data transmission. RSA is widely used to secure data transmission over the internet, including web traffic and email communications. And digital signatures. Nowadays, it has become a common doing digital signatures. So RSA is essential for digital signatures, which are used to ensure the uh, authenticity and integrity of digital documents and messages. And secure email communications. RSA is employed in email encryption protocols like SMIME and OpenPGP to secure email communications and secure payment transactions. RSA is integral to um, securing online payment transactions. When you make an online purchase or conduct online banking or RSA encryption is often used to protect your financial information such as credit card numbers and personal identification details during the transaction process. And what will be the future of RSA algorithm? Next coming features for RSA algorithm are quantum resistance cryptography, developing the encryption methods resilient to quantum attacks as quantum computers advance, and lattice-based encryption, exploring cryptography approaches based on the mathematical hardness of lattice problems and privacy preserving computation, utilizing multi-party computation for secure collaborative computations without revealing sensitive data. And homography encryption integration, integrating homography encryption for secure computations on encrypted data without decryption. Blockchain centric security, implementing cryptography techniques to enhance security in decentralized system like blockchains. Now we are at the end of the video. Let us summarize what is RSA algorithm. The RSA algorithm introduced in 1977 in a prominent public key crypto system, which key components include a pair of public and private key. Security relies on the difficult of factoring larger numbers, larger prime numbers. Key generations involves selecting prime, creating models, and driving exponents. Encryption uses the recipient's public key, while decryption requires the private key. RSA security strength is ensured by key length with a longer key recommended as computing power advance. The algorithm is versatile, applied in secure communication, digital signatures, and serves as a fundamental element in modern cryptography, inspiring subsequent developments. Um, Thank you.